To find the velocity, we have to derive the displacement. So velocity means derivative of displacement, that is ds by dt. When you derive it, you will get 20 minus ATT. So we get 48, it is 0, minus 2, which is less than 0. Less than 0 means it is negative. So therefore we can say P is maximum, that is their product is maximum. For initial velocity, you have to consider time as 0, and for final velocity, you have to consider velocity as 0. Hello everyone, a warm welcome to one and all. This is your Shruti ma'am lecturing in Vidhyaashram, the Temple of Excellence, Mysuru. We are at the revision of chapter-wise question and answer. So in this session, we will be discussing on 2-mark question as well as 3-mark question from the chapter Application of Derivative. Let's see the distribution of marks from this chapter. In this chapter, you will be having 1 2-mark question and 2 3-mark question. So that is in total, you will be having 8 marks from the chapter Application of Derivative. Let's see the type of question they may ask you for your examination. So here is our first question. The displacement S of a particle at a time t is given by S is equal to 4t cubed minus 6t square plus t minus 7. Find the velocity and acceleration when t is equal to 2 seconds. We know that velocity is nothing but rate of change of displacement with respect to time. So therefore, rate of change of is always the small change in the one quantity with respect to another quantity. Hence, here rate of change of displacement is given by ds by dt, that is change of displacement with respect to time. So therefore, to find the velocity, we need to derive the given function. So if you derive this function, it is 4 into 3t square minus 6 into 2t plus derivative of t is 1 and derivative of a constant is 0. Hence, we get velocity is equal to 4 3s are 12t square minus 12t plus 1. Now they have given, we have to find the velocity and acceleration when t is equal to 2 seconds. So at t is equal to 2, velocity become 12 into 2 square is 4 minus 12 into 2 plus 1. That is 48 minus 24 plus 1, which becomes 25. Next, we need to find out the acceleration. Acceleration is nothing but rate of change of velocity with respect to time. Or we have to derive the displacement twice. So if you find the second order derivative of the displacement, then it is nothing but acceleration. Or first find the velocity, then again differentiate to get an acceleration. So however you derive it, you will get an acceleration as dv by dt. So this is our dv by dt. So if you derive it, you will get 12 2s are 24t minus 12. Now at time t is equal to 2 seconds, we have 48 minus 12, that is equal to 36. So this is the acceleration. Next question. When the brakes are applied to moving car, the car travels a distance s feet in t second given by s is equal to 20t minus 40t square. When does the car stops? So the condition the car stops means the final velocity is 0. So therefore, we can take the velocity is equal to 0. Now we have to find out, so when does the car stop? That is, we have to find out the time. So to find out the time, we need velocity. To find the velocity, we have to derive the displacement. So velocity means derivative of displacement, that is ds by dt. When you derive it, you will get 20 minus ATT. So velocity is 0, 20 minus ATT. So here we get ATT is equal to 20, T is equal to 20 by 80. So when you cancel, you will get 1 by 4, or we can write T is equal to 0.25 seconds. So the car stops at time 0.25 second. Next, the radius of a sphere is increasing at the rate of 0.5 meter per second. Since they have given a distance with respect to time, the rate of change of radius is given by dr by dt. So that is given 0.5 meter per second. Find the rate of increase of its surface area and volume after 3 seconds. We need to find out dA by dt as well as dV by dt when time is equal to 3 seconds. So since we have here dr by dt is equal to 0.5, we can write dr is equal to 0.5 into dt. So this is the small change of the radius with respect to time. We can also write this in the form of r is equal to 0.5 into t. Now t is given, that is 3 seconds. So therefore r is equal to 0.5 into 3. So which you will get it as 1.5. Hence we get r is equal to 1.5. Now we will find out the area of a sphere and a volume of a sphere, that is rate of change of area as well as the rate of change of volume. First let us find out the rate of change of area. So we know that area is equal to 4 pi r square. So therefore dA by dt is nothing but 4 pi, derivative of r square is 2r into dr by dt. So here we get 4 pi into 2 into 1.5 because r we got it as 1.5 and dr by dt is given as 0.5. So after multiplying the value, we get the rate of change of area is equal to 6 meter square per second. Since this is an area, we have to write the unit in terms of square unit. Next, we need to calculate the volume. So volume is V is equal to 4 by 3 pi r cube. So volume is dV by dt is equal to 4 by 3 pi. R cube is 3r square into dr by dt. So we can cancel 3 here. So we have 4 pi r square is nothing but 1.5 whole square and dr by dt is nothing but 0.5. So after multiplying this completely, we will get dV by dt is equal to 4.5 meter cube per second. So this is the change of volume with respect to time. Next question. The sum of two natural number is 48. Find the numbers when their product is maximum. The product is maximum means the second order derivative must be a negative value. Let's see whether their product is maximum. So the sum of two natural number is 48 they have given. So let me take x plus y is equal to 48. Then I can write y is equal to 48 minus x. Given condition is their product is maximum. Let me take their product as x into y, which can be written as x into 48 minus x. So we get p is equal to 48x minus x square. Now let's derive the function with respect to x. So we have here dp by dx is equal to 48x is 48 minus 2x. Put this is equal to 0. Put dp by dx is equal to 0. So this implies 48 minus 2x is equal to 0. 2x is equal to 48. So therefore we get x is equal to 24. Now we have x is equal to 24. So let me take this as equation, this as equation 1, this as equation 2. Now derive equation 2 again, then it becomes d square p by dx square. So which is 48. 48 is a positive quantity which is greater than 0. So we get 48 it is 0 minus 2 which is less than 0. Less than 0 means it is negative. So therefore we can say p is maximum. That is, their product is maximum. So therefore, x is equal to 24, and what is y? Y is 48 minus x, which is 48 minus 24 is equal to 24. So therefore, the numbers are, or the two numbers are 24 and 24. So first, find out the given condition, verify their product is maximum. If it is true, then we can take the number is 24 and the other number is 48 minus 24, which is 24. Next one, if s is equal to 2t square plus 4t minus 8, find the initial velocity and acceleration. So given here, s is equal to 2t square plus 4t minus 8. So we have to find out the initial velocity. So that is v. V is equal to ds by dt. ds by dt means derive it again. So t square is 2t. 2 into 2 becomes 4t plus 4. So here we have to take here t is equal to 0 because initial velocity means the time is 0. So if you put t is equal to 0, then velocity is equal to, so 4 into 2 becomes 0, so 4, hence velocity is 4. For initial velocity, you have to consider time as 0, and for final velocity, you have to consider velocity as 0. Next, we have to find the acceleration. Derive acceleration from the velocity. So, or you can take a is equal to d square s by dt square, or you can write it in the form of dv by dt. So therefore, acceleration is 4 again, because 4t means you will get 4 and derivation of 4 is 0. Hence, the acceleration is also 4. Velocity at time 0, initial velocity is 4. Next one, find the average cost and marginal cost of an output of 10 units if the total cost function of an article is given by C is equal to 5x square plus 2x plus 3. So here the total cost function, that is C of x, is given in the form of 5x square plus 2x plus 3. Average cost is nothing but total cost divided by x. So you have to divide this completely by x, then you get it as 5x plus 2 plus 3 by x. Now we need to find out whenever the output is 10 unit. So therefore, average cost is equal to, when x is equal to 10, 5 2s are 10 plus 2 plus 3 by 10. So 3 by 10 is nothing but 0.3. 12 plus 0.3 becomes 12.3. So this is the average cost. Next, we need to find out the marginal cost. So marginal cost is nothing but derivative of total cost. So what is derivative of total cost here? 5x square means it becomes 10x, and derivative of 2x is 2, derivative of 3 is 0. Now at x is equal to 10, so marginal cost is, so 10 tens are 100 plus 2 is equal to 102. Next one, the displacement s of a particle at time t is given by s is equal to root of 1 minus t. Show that the velocity is inversely proportional to the displacement. We have s is equal to root of 1 minus t. To find the velocity, it is nothing but derivative of s, that is ds by dt. So velocity is nothing but derivative of root of 1 minus t. Anything in the form of root x is nothing but 1 by 2 root x. So therefore, here the derivative becomes 1 divided by 2 root of 1 minus t. But what is root of 1 minus t? This is nothing but s. So we get v is equal to 1 by 2s. Or if you remove the equality, we can include a proportionality constant. We get v is proportional to 1 over s. Clearly you can see they are inversely proportional to each other. Hence we can say velocity is inversely proportional to displacement. Next one, if the total cost function of an article is given by C is equal to x cube minus 3x plus 7, find the average cost and marginal cost. I already said you average cost means it is total cost divided by x. So it is given x cube minus 3x plus 7. Hence average cost is nothing but total cost divided by x. So divide the equation by x, you will get x square minus 3 plus 7 by x. And marginal cost is derivative of total cost function. So you have to derive the total cost function, that is 3x square minus 3. So this is the marginal cost and average cost of the given function. Next one, we will move on for 3-mark question. A circular patch of oil spreads on water, the area growing at the rate of 16 centimeters square per minute. How fast are radius and circumference increasing when the diameter is 12 centimeter? They have given that the area of the circular patch of oil increases at the rate of 16 centimeters square per minute. That is change in area. So dA by dt given 16 centimeter square per minute. Now we need to find out the change in radius, that is dr by dt, and change in circumference, that is dc by dt, when diameter is equal to 12 centimeter. Now if diameter is 12 centimeter, what about the radius? R will be equal to 6 centimeter. Now take, since it's a circular patch of oil, the area of the circular patch of oil is pi r square. If you derive with respect to time, we get dA by dt is equal to pi into 2r into dr by dt. So here we have dA by dt as 16, pi into 2, r we can take it as 6, and we need to calculate dr by dt. So we get here 2 ones are 2 8s are. So we get dr by dt is equal to 8 divided by 6 pi. So cancelling 2 4s are 2 3s are, we get 4 divided by 3 pi. So centimeter. So this is per minute. Change in radius with respect to time. Now next we need to calculate the change in circumference, that is dc by dt. So we know that circumference is equal to 2 pi r. So dc by dt is nothing but 2 pi into dr by dt. So 2 pi into dr by dt, we got it as 4 by 3 pi. So 4 divided by 3 pi, pi get cancels. So therefore dc by dt is 8 centimeter per minute. So this is the change in circumference of the circular patch of oil. Next, find the maximum and minimum value of the function f of x is equal to x cube minus 3. So this is also one of the important question which you may get for 3 marks. Since you have 2 3-mark questions from this chapter, one will be from the rate measure, the other will be either from maxima or minima or from the total cost function. Now here we have to find the maxima and minimum value, that is maxima and minima of the given function. So first they have given f of x is equal to x cube minus 3x. Find f dash of x. F dash of x is nothing but 3x square minus 3. Now to find the critical points, put f dash of x is equal to 0. So put f dash of x is equal to 0, then we get 3 square minus 3 is equal to 0. So 3x square is equal to 3, 3 get cancels, x square is equal to 1, x is equal to plus or minus 1. Now these are the critical points, that is x is equal to plus 1 and minus 1. Now let us derive the function again to find the second order. So f dash of x is nothing but here 3x square, which becomes 6x. Now at x is equal to 1, f double dash of x is equal to 6, which is greater than 0. So therefore, what we can conclude, it has minimum value. It has minimum value. Now what is that minimum value? Put x is equal to 1 in the given equation. So therefore, f of 1 is equal to, don't put in f double dash of 1, take the function in the form of f of x. Once you got it has a minimum value, you have to take the critical point and substitute in the given function. So this becomes 1 cube minus, we have it as 3x, that is 3, which becomes minus 2. So therefore, the minimum value is minus 2. Next we have one more critical point, that is at x is equal to minus 1. At x is equal to minus 1, here f double dash of x becomes minus 6, which is less than 0. If the second order derivative is negative, then it has maximum value. It has maxima, you can take. It has maxima or it has minima. So therefore, f of minus 1 is equal to minus 1 whole cube minus 3 of minus 1, which becomes plus 3 minus 1, which is 2. So therefore, the maximum value of the function is 2. So first find out f dash of x, put f dash of x is equal to 0, find critical point, then find second order derivative. So by substituting the critical value, find where you have the maximum value, where you have the minimum value. And using that critical points, if you get a maximum value or minimum value, find the maxima and minima by substituting the value of critical points in the given function. You will get the maxima and minima. So the maximum and minimum value is nothing but the maxima and minima of the function. Next, if the total cost function is given by C of x is equal to 350 plus 12x plus x square by 4 and revenue function is given by R of x is equal to 75x minus 2x square, find the level of output at which the profit is maximum. So here we have C of x is equal to 350 plus 12x plus x square by 4. And one more we have R of x. R of x is given by 75x minus x square. Now the condition here, we have to find the level of output whenever profit is maximum. So profit maximization or profit is maximum when marginal revenue is equal to marginal cost. So how to find out the marginal revenue and marginal cost? If you derive the total cost, you will get the marginal cost. That is 0, 12 plus 2x by 4 becomes x by 2. And similarly, if you derive the total revenue, you will get the marginal revenue, that is 75 minus 2x. Now equate both of them. So marginal revenue is 75 minus 2x, marginal cost is 12 plus x divided by 2. Multiply 2, so you will get 150, so 2 2s are 4x, 12 2s are 24, 2 into 2x by 2 becomes 2x. Next, so you will get 5x is equal to 126. So x is equal to 126 by 5. So this is the output where the profit is maximum. Next one, if s is equal to 2t cube minus 5t square plus 4t minus 3, find the time when the acceleration is 14 feet per second square, the velocity and displacement at the time. So first we have the equation s is equal to 2t cube minus 5t square plus 4t minus 3. So let's write the equation. S is equal to 2t cube minus 5t square plus 4t minus 3. Take this as equation 1. Now to find the velocity, we have to derive this equation once. So which is 2 into 3t square minus 5 into 2t plus 4 into 1 minus 0. So we get velocity is equal to 2 3s are 6t square minus 10t plus 4. Take this as equation 2. To find the acceleration, derive velocity. It becomes 6 into 2t minus 10 into 1 plus 0. So acceleration is equal to 12t minus 10. Now, they have given first question, that is, find the time when the acceleration is 14 feet per second square. Let me take this as equation 3. So, from equation 3, let us substitute acceleration is equal to 14, 12t minus 10. Minus 10 when it goes here, it becomes 24 is equal to 12t. So, divide by 12. So, therefore, we will get time is equal to 2 seconds. Now, after finding time, we need to calculate the velocity and displacement at that time. So, velocity, we have an equation, that is v is equal to 6t square minus 10t plus 4. At t is equal to 2 seconds, velocity is 24 minus 20 plus 4. So, which is equal to 8 feet per second. Next, we need to calculate the displacement. Displacement is 2t cube minus 5t square plus 4t minus 3. So, again at t is equal to 2 seconds, s is equal to 2 into 2 cube is 8 minus 5 into 2 square is 4 plus 4 into 2 minus 3. So, that is 16 minus 20 plus 8 minus 3. So, therefore, x is equal to 1 feet. So, this is the velocity and displacement at time 2 seconds. So, we will take up few more problems in our next session on 3-mark question from this chapter. Until then, keep watching, keep learning, keep exploring. Thank you.